Hello again. I'm Keith Light, Engineering Technical Leader at GE Critical Power. Thanks for joining us for part 2 in our series on thermal derating. To verify that the module is operating correctly and as expected, prior to the thermal testing, a complete set of efficiency and power dissipation curves of the test module are obtained via automated testing at various ambient temperatures. Next, the critical components must be identified and thermocoupled. Critical components are those components that limit the thermal performance of the module. These typically include the power MOSFETs, control ICs, magnetic cores, opticouplers, input and output capacitors, and the printed circuit board itself. Proper selection and application of thermocouples is critical to correct and meaningful results. If a thermocouple is applied incorrectly to a component, then this can result in inaccurate measurements which will affect the end results. This is becoming more important as component sizes decrease because the thermocouple itself can actually affect the component's temperature. It is also important to identify critical components with the help of an IR camera. An IR image of the module under different operating conditions can identify components which may be running hotter than expected or perhaps are located in a hotter location on the board and therefore can become critical components. The IR camera is also used to identify potential issues during transient conditions like startup, OTP, or short circuit. As described earlier, derating curves are generated by plotting operating points at particular airflows and ambient temperatures across the entire operating range of the converter. Therefore, these tests must be performed in a wind tunnel, which is capable of accurately providing uniformly heated airflow up to 600 LFM or greater and up to 105 degrees C ambient temperatures. The converter is soldered to a test board, which simulates the customer's circuit board. This test board is then mounted into the wind tunnel, and an offset test board is placed opposite the module to create a channel through which the controlled airflow will pass over the module. An anemometer used to measure the airflow and an ambient thermocouple are placed 3 inches below the module to measure the input airflow and temperature. The testing is then started. The testing is performed using an in-house custom automated test program which continuously monitors all thermocouple component temperatures and continuously monitors and controls the airflow, ambient temperature, and output load to maintain the desired settings throughout the test. It is important that the parameters are continuously monitored and controlled throughout the test because set points tend to drift during testing. We hope you'll continue to part 3 of our series on thermal derating and design to learn about a number of factors that can have a big impact on results. In the meantime, if we can help with selecting and testing the right power module for your application or answer any questions, please let us hear from you.